Thank you. And particularly a big thanks to Mark and Stuart for laying on this event. I think it's an extremely good initiative to get us semiconductor companies together. It's the first time it's been done, as far as I'm aware, in Australia. And it's interesting to see there's more and more semiconductor companies sort of emerging here and coming out from the US. We're one of the ones who've been around for some time. We've been listed since 2006, doing fundamental research. We're based entirely here in Australia, in Sydney. And I'll talk about what we're up to. Starting with, look, we're a platform technology. So we have a equipment and process for high efficiency optoelectronic devices. So the area that we're in is LEDs, solar cells, power electronics, micro LEDs, rapidly growing markets where they're driven by efficiency. So it's all about bringing the cost down and driving the efficiencies up. And that's really what BluGlass is all about. We've been around, let's say, since 2006. That's when we listed. We came out of Macquarie University, so years of fundamental research there. The technology looked really promising. The ASX looked like a great platform to raise money. So we brought the technology out of the university, raised the money to come and carry on with the fundamental research. It was really early on in the technology. We were really just doing basic research. But it allowed us, the ASX, to raise the money, keep the research going, build our facility, develop the team, develop our core capability, and actually have the breakthroughs that we needed to get to the commercialization point. In that, we filed a bunch of IP patents, which I'll talk about in a minute. And we've now developed a really good sort of team of people, network of businesses that we're working with, and some fundamentally really good technology. So the markets we play into, and I'll come to the actual technology in a minute, but the markets we play into are all high growth markets where it's efficiency and cost drive these markets. So there's the LED market. We're all familiar with LEDs. They're in our backlighting on mobile phones. We see them in the automotive industry. We had Revorsum talking about all these downstream customers getting more and more sophisticated in how they use technology. We're playing into those sort of markets. You see LEDs used in automotive applications, daytime running lights, high beam, low beam lightings. That's a market which is huge and continues to grow, and efficiencies drive that market. Then there's a new market here called micro LEDs. Micro LEDs is really an alternative display market. So when you're talking about micro displays, units getting smaller and smaller, such as mobile phones and wearables, watches, they're using smaller and smaller displays on that where they need to be efficient, consume less power, and this now moving towards sort of a technology called micro LEDs. So that's another area that we're looking at as well. And then there's power electronics. So as a platform technology, we're in the gallium nitride equipment space. There's a plethora of different applications for our technology. But being a relatively small company, we've decided to focus on 3 or 4 areas where we can see rapid growth, where we can apply our technology and get rapid commercialization. So this is just a bit of a sort of timeline where we came from. So been listed for nearly 12 years. The first 6 years of our existence was really just focusing on the fundamental technology. We have a technology called RPCVD, remote plasma chemical vapor deposition, real mouthful, but it's a reactor and a process for making these devices. So the first 6 years was really just getting that technology bedded down and right. And then in 2012, we had a breakthrough. The technology worked. We proved the fundamental capability of the technology. And then from there, we've been working through various proof of concept milestones, engaging with the industry. So we have a number of key industry collaborations that have helped us advance the technology and a number of breakthroughs along the way. Probably the most significant one was one which we had last year, a thing called tunnel junctions. And again, I won't go into too much detail, the technology, but what it is really about driving up efficiencies of LEDs. It's something that the industry have been looking for a long time. It's very hard to do with the incumbent technology. We've demonstrated some capability there. It's one about driving down cost, driving up efficiency, and we're now taking that out to the LED industry as a whole. And then more recently, we announced one of our customers embedded our technology in one of their prototype products, which they demonstrated to the world. And that's in the micro LED display technology. And I'll come to that again in a minute. In terms of what underpins this, we've got a pretty extensive patent portfolio. We have 8 patent families, core patent families. Some of that came from the university when we originally developed the technology, and then we built on that over the years. And we now have 63 granted patents around the world in all the key semiconductor countries, Taiwan, Korea, Japan, US, etc. And there's a nice pipeline of patents coming through. So there's another 14 applications in there. But the fundamental technology we have is broadly protected, and we'll continue to build on that, both process patents and equipment as well. In terms of sort of the financial position where we stand, we do generate revenue, but it's relatively small. The company is really predicated on a licensing play, and I'll talk a bit about that further down the track. But the revenue that we generate at the moment is through contract manufacturing. So we have manufacturing we do of prototype high-end devices for customers, and it's really an opportunity for them to try out the technology, generates good margin revenue for us, but ultimately leads as a strategic vehicle to sort of licensing and collaboration deals. So we'll see that revenue going up. Our burn rate has gone up marginally recently as we've increased the size of facilities. So we've got 1,200 square meters in Silverwater, just 45 minutes west of here. We've just doubled the capacity of our facility, added on extra team, extra equipment as well. So our burn rate has gone up marginally. But most of our work is research at the moment. We do get the R&D tax rebate, so we see 2 million coming back to us through the R&D tax rebate, and that will grow again this year. And our cash position is pretty robust at 8.7 last reported. In terms of the people, and I'll just touch on this briefly, we're mostly based here. Our research team is based here. It's a flat structure. We have 25 people, I think it's 11 PhDs. They came from the university or from the industry. As I say, based in Silverwater. We have a presence in the US as well, and we have a presence in Europe, but all the research happens here. We've got a world-class team of people who drive that through. Myself, I've been running the business since just after listing. We have a CTO who came out of the industry, out of North America, and the rest of the team are sort of mishmash of people that have come from universities or from industry from all over the world. And just briefly touching on the board as well, our board is nicely balanced between commercial people, so we've got a couple of board members here today who understand governance and the commercial side of the business, and we have two highly respected semiconductor people in Silicon Valley. In fact, we have a common board member with Revorsum. One of our board members, Vivek, also sits on the board of Revorsum as well. Now let me just touch briefly on the technology, the market, and where we're going and sort of the next steps for us. So from a technology, just looking at this sort of these images here, these are all taken from inside our facility. On the left are the actual machines, the reactors that we develop. So a bit of background there, we used to build our own machines from the ground up. It made sense sort of as we went through our development cycle, rather than reinventing the wheel, we took the incumbent technology, it's called MOCVD, and we just retrofitted it and put our own special sauce in it, as you said. So we took out a core process module, replaced it with own hardware that is unique to us, and then kept the same chassis that's used widely by the industry, which sort of plays into our business model as well. So those two machines on the left, they're in our facility. In those machines, and we've heard about this a bit today, there are wafers grown in those machines. So we use, in this particular case, we use sapphire, synthetic sapphire, but we are wafer agnostic. So it could be silicon carbide, it doesn't really matter. It just happens to be the LED industry at the moment is traditionally on sapphire. So in that reactor would sit maybe 40-odd 2-inch sapphire wafers, and on each 2-inch wafer, you'd have about 10,000 LED chips grown over a process which takes about 8 hours. So that gives you an idea sort of the throughput of these machines. So it's a very complex process to grow out of physics and chemistry, but ultimately what you end up with is a wafer with all the chips grown on it, then you have to slice it up and actually remove the chip. So we have downstream, and on the right here, downstream characterization and processing that we also do on site. So all of this is contained out of our facility in Silverwater. So what is it we actually do? So right now, to grow an LED chip or these types of high efficiency gallium nitride chips, they use a process called MOCVD. And MOCVD is a high temperature tool. So the fundamental limitation of the equipment that's used in the industry is the temperature it operates at. And it needs to operate at a high temperature. The high temperature is used to basically break down the gases that come into their atomic species. What we do is we operate on a similar architecture, but we introduce different gases through a different process, which allows us to operate at a much, much lower temperature. And the fundamental difference is the lower temperature means that you get better quality films and higher performance. And in the case of an LED, more light output. And that is the fundamental difference of what we do. So the core process module chamber within these reactors, we replace it with our own RPCVD chamber. So just taking one example of the LED industry, a lot of big LED players out there. There's Cree, there's Lumileds, there's Osram. I'm sure you've heard of them. They're selling LED modules into automotive applications, general lighting. But what drives them is lumens per dollar. And so all of them are trying to get more lumens out at a lower cost. So what we just recently launched was a thing called a tunnel junction cascade LED, and that basically targets a greater than 10% light output improvement based on lumens per dollar. That is really significant for the industry. And right now we're sort of sharing that with industry as a whole. And part of our business model is to engage in a sort of collaboration with the industry to license that technology out. Just changing gears, one of the other applications in this platform technology is micro LEDs. And so one of our customers, and I say we have a handful of customers who use RPCVD, launched this application at the Consumer Electronics Show in Las Vegas earlier this year. And basically what this is a screen not too dissimilar, say, from an iPhone type screen using micro LEDs. And their expertise is transfer technology. But that was enabled by us. So it's got a BluGlass produced RPCVD chip in that allowed this to happen on micro LEDs. Micro LEDs is a sort of investments happening with all the big OEMs, so all the people who manufacture wearables or phones, et cetera, investing this as a sort of next generation of display technology beyond OLEDs. So we think this is pretty significant. Although it's a market that's pretty much non-existent today, there's an enormous amount of investment going on it and an enormous amount of investment from the big OEM manufacturers. So for us to have our technology already sort of incorporated in examples of micro LEDs is pretty critical. So that was an announcement we put out a couple of weeks ago. Let's just briefly talk about the markets we're playing to. And really, rather than looking at all the markets, I just really want to focus just on the big one, which is the LED market. So the LED market, as we know it today, is divided up into lots of different applications. But the two dominant ones are the general lighting and the automotive lighting. That accounts for about 56% of the market, on a market that's worth $16.7 billion in 2018 and continues to grow. The people who make these devices listed there, that's the top 10, Nichia, Osram, Lumileds, Seoul Semiconductor. There's plenty of others as well who are involved in it. Names you might not have heard of. Like Jerry said from Revorsum, these are the people who then would package up these LEDs, which would go to these sort of manufacturers of automotive, Mercedes or Tesla, et cetera. So that's our customer. They're the people that we're working with, the LED companies. And on that list of 10, we are actively engaged or talking to a number of those people. So if we take just the automotive and the general lighting, the 56% of that 16.7 billion market, that's the sort of high performance devices, always striving to get more lumens per watt out there. So we're really looking at that. So we then break that down into what's our share of the pie there. Well, as a license-based business, we've got this hardware, which we did sell into the manufacturers, but we also intend to license the process. And so we see that out of that sort of 56%, we take a slice of that through a licensing revenue. Now, I'm not telling you what that is today because that's a work in progress and we're engaging with the industry right now, but we've modeled that out extensively. So it's a license-based business, also a foundry, contract manufacturing business, and then there's an equipment component that goes in as well, which is about retrofitting the installed base in these manufacturers or providing new machines. So just talking about our revenue generating business. So we have this business called EpiBlu, and EpiBlu simply uses our technology over here in Silverwater, and we just produce materials for customers on a range of different applications, from high-powered lighting to laser diodes to micro LEDs. And we have half a dozen customers at this moment in time, generally fairly small production runs, but it's high margin work. But ultimately for us, it's a strategic vehicle. It's a way of engaging with these people that if they start embedding this as prototype technology, they ultimately want to scale up. And for us, it's a partnership and then a future licensing opportunity for the business. But it's a revenue stream in its own right. So we'll continue to grow that side of our business, not only for revenue opportunity, but for future licensing and partnering. Just sort of looking forward, sort of summarizing sort of where we're up to and what we're going to. So the path to market on the left here, this gives you a sort of range of the applications we're looking at. So at the top is probably the ones we spend most of our effort on, high brightness LEDs, micro LEDs. But there's a range of other different applications where you can apply this compound materials, these gallium nitride materials. And so we've looked or worked at in most of these areas, and we prioritize them based on sort of market opportunity. And where we, as I said, where we would derive our sort of revenue and our commercial opportunity is a combination of licensing and royalty fees, contract manufacturing, which obviously is ongoing right now. There's equipment sales, so either new equipment, and we work with one of the biggest equipment partners in this business, or actual retrofit of existing installed base. So there's really sort of multiple avenues for sort of deriving revenue from it. But the sort of key message here, it is a platform technology. We've got this fundamental sort of RPCVD technology and lots of different ways of applying it. Most of our effort really to date has been on the LED space, but we see lots of other opportunities emerging, and we will look at them in due course. But really trying to remain focused on sort of a couple of key ones is critical. So sort of going forward, what are the sort of the key drivers to sort of get us through to the commercialization? Somehow it's got sort of disjointed here. I don't know what's happened in the formatting, so apologies. But the sort of key things that we're doing at the moment is we've got a facility that is just being doubled in capacity. The equipment that we work on is production equipment. We've just installed current production equipment there, which is to deal with the scaling. So we're scaling up the technology to make it applicable to the technology that's used right now in the LED manufacturing plants. We've got a material out there called tunnel junctions, which is resonating very well with the industry. We'll continue to build on that and enter into more collaborations with the industry. So we're already working with a number of key players, and we expect to work with more. So we'll continue to negotiate that. And then obviously the revenue generating side of our business, which is the EpiBlue, the foundry, we will again grow that as well. So just to summarize, I don't know if I'm on time, I hope I'm on time, but who knows, I haven't looked at my watch. But key to us is we're playing into high performance semiconductor devices, growth opportunities. They're all markets that are growing, as we see the automotive, as the automotive becomes more and more automated. We're playing into these markets that are growing very rapidly, and new ones are emerging all the time. We've got a very good team of experts working on this. We are engaged with major players within the industry already, so we are working very closely with them. We have a world-class facility, a very good IP portfolio. So I think we're very well positioned to sort of take this all the way through to commercialization. We're all pretty excited about it. Thank you.